All right, welcome to the first video in the functions unit. This one is on the properties of a function. Let's see what those are. Okay, now when we talk about functions, we're just using a fancy word to talk about the relationship between two variables. And we have seen one function over and over again already in this course, and that's the linear function y equals ax plus b. Now when we studied y equals ax plus b, we called that linear relations, but really that relationship between x and y could also be called a function. So those straight lines are actually called linear functions. So those straight lines that we studied, those linear functions, all it meant in that relationship between x and y is that every time the x value changed, the y value changed by some specified amount also, called the rate of change. And that's really all a function is. It's a representation of the relationship between x and y, and how when x changes, the y is going to change accordingly. And remember, it's the fact that x is the independent variable and y is the dependent variable that causes that change to be by some predictable amount. Now, what gets a little bit tricky is that not every function is going to change as a straight line like the y equals ax plus b function did. So some of these new ones are going to be curved lines or pieces of straight lines that come together to form a graph, but we're going to study the different types of functions in future videos. For now, we'll focus on the properties of functions and some of the things you have to know about that. Now first I'm going to explain to you what we do when we see the notation of the letter f followed by an x in brackets. Now this is a symbol we're going to see really often when we study functions, and we actually read this f of x. That f bracket x is read as f of x. And really what it stands for is a function of x. All it really does though is represent the exact same thing as y. And this makes sense if we remember that the y variable is dependent on the x variable. Another way of saying that y depends on x is that y is a function of x. So that's where function of x, or f of x instead of writing y, comes from. So anytime we see this f of x symbol, we can actually write y above or below it just to remind us that f of x just means y. Now on to the real point of the video. When we talk about the properties of functions, what we're really talking about are just the characteristics of a function. And the characteristics that we'll explore in this video are domain, range, maximum and minimum values, also called the extrema, the initial value and the zeros of a function, positive and negative values in a function, and parts of a function that are either increasing, decreasing, or constant. Now, before we get into it, I have to remind you again, we're not always going to see functions that are just linear. That means they're not always just going to be in a straight line. And that sometimes these lines, whether they're curved or straight, are going to change direction, and that a function might be made up of several different rules that describe what we're seeing on a graph. Now, first up for us to look at are domain and range of a function. First, with domain, these are the possible x values that are included in a given function. So if we look at the graph on the screen here, we can notice even though it has a few different parts to it, this graph never has an x value that's smaller than -4 or larger than 11. So in this case, I would simply say that the domain of this function is from -4 to 11. However, it's not quite that easy. We have to be aware of a couple of things here. Now first up is that open circle where the function ends at the x value of 11. The open circle just means that we don't include the value 11 in this function. So what it means is, with an open circle, this line that ends at 11 is going to be infinitely close to 11. Think of 10.9 repeating as many times as you can picture it, but never actually reaching a value of 11. So the open circle just means we get as close as possible with that line to 11 without actually ever reaching it. So we're not going to include 11 in the domain of this function. Now notice how at an x value of -4, there's a full circle at the end of the line. That means we do include that -4 value. So with a full circle, we include the value. With an empty circle, we don't include that number in the function. Now we just need to figure out the proper format in which we can answer the domain of a function. And it simply looks like this. This is something called an interval. And notice how at the front end of this interval, the bracket is facing the -4, kind of hugging that -4 value. That implies that we include the -4 in our domain. Remember, it had a full circle at -4. But now look at that bracket beside the 11. It kind of is turned away from the number. It has its back turned to the 11. meaning that this interval of numbers for domain is going to get extremely, infinitely close to 11, but never actually include the value 11. So when we want to exclude a number from an interval, we take that bracket and we turn it away from the number. So if we look again at the graph, the domain is all the possible x values in this function, and it's from -4 to 11. But the full circle at -4 means we include that number, and the empty circle at 11 means we don't include 11 in the domain. So next up is the range of a function, and this is going to be a little bit quicker than domain because it's the exact same thing except for y values instead of x values. So range are all the possible y values that are given in any function. So for the function that's shown on the screen, we can see that even though it has a few ups and downs in it, the y values never dip below 2. And when we're looking at the highest possible y value, well, if we look at the arrow at the end of that line on the right, we're going to remember that that means the line goes on forever. So this is going to climb to infinity on the y-axis. This line is never going to stop going up. So this means we don't actually have a high end of our range. It goes on until infinity. So here then, my range would be from 2 to infinity, with a square bracket hugging the 2 because I include that value. And at infinity, I have to actually turn the bracket away from infinity, because by default, I can't actually include a number that doesn't really exist. So that's the range. It's just the possible y values in a function. And now for something called the extrema, the maximum and minimum values of a function. These are actually the two values that you're going to use in your range also. It's the smallest y value to the highest y value for minimum and maximum. So if we take a look at this example here, you can see that the y never dips below -9. So I've got a y value minimum of -9, and the y values never reach above 2.5. So I've got a maximum value of positive 2.5. And that's all I have to know about minimum and maximum or extrema values. Now the initial value of a function is simply the point where the function crosses over the y-axis. Now remember, from past lessons we've already learned that the y-intercept and the initial value are the exact same thing. And any function, no matter what it looks like or how it's drawn, is only going to have one initial value. There will only ever be one point where it crosses the y-axis, and we're going to use this as our initial value. So for the function that we see here, the initial value is -5. Now any function can only have one initial value. However, it could have multiple values that are called zeros. And zeros are just the points where a function will cross the x-axis. And the reason we call these points where the function crosses the x-axis as zeros is because at each of these points, we know the function has a y value of 0. And by now you've probably recalled that we also call zeros x-intercepts of a line or a function. And now we know that it's possible that we can have more than one x-intercept in any given function, just like the 3 of them that you see on the screen right here. So that's initial value and zeros. Initial value is the y-intercept, and the zeros, there could be many, are the x-intercepts of a function. So now on to positive and negative values. These are really easy to spot, but kind of difficult to answer in the proper notation. Positive values are any values in a function that are above the x-axis. Think of a thermometer where the x-axis represents 0, and any numbers that are above the x-axis represents positive temperatures on that thermometer. And negative values, well, you guessed it, those are values that are below the x-axis, or on a thermometer below 0, representing negative temperatures. Now the answers here are going to be intervals of x values, for which we have positive or negative portions of our function. So because we're answering in intervals here, we're going to use that proper interval notation that we learned for domain and range. So in this function here, you can see that I'm above 0. I've got positive values in the interval between -1 and +5. Because at exactly -1 and 5, I've got zeros, but between those two values, my function is entirely above the x-axis. So the function in that interval is positive. Now in that interval, I'm not including the -1 or the 5. Notice how the brackets are turned away. That's because at -1 and 5, the function's actually 0. So it's only between those values, but not including them, that the function is positive. And now we have two intervals, though, where the function is negative. And the first interval that I see where this function is negative is from -8 to -1. Notice, though, that I'm including the -8 value because of that full circle, but I'm not including the -1 because it's a 0. So it's from -8 up until, but not including, -1 for the first negative interval. And the second portion of this function that's below 0 or negative is from 5 to 9.5. And I will exclude the 5 because it's a 0, and I will also exclude the 9.5 because of that open circle at the end of the line. So my second negative portion is in the interval from 5 to 9.5, excluding both values. Now finally, we have increasing, decreasing, and constant portions of a function. And these are as easy as any of the properties that we've looked at so far. Increasing portions of a function are any portion of the function that has a positive slope to it. Decreasing portions of a function have a negative slope, and constant portions of a function are represented by perfectly flat horizontal lines. Now here, the answers for increasing, decreasing, and constant are again going to be intervals of x values, for which the function is either increasing, decreasing, or constant. So it should be pretty obvious when we look at where this graph is increasing. It's increasing from the interval between -6 and -1, and then again in the interval between 4 and 8. The function is then decreasing from 8 until infinity. Remember, the arrow at the end of the line means the line will never stop going. So this line after 8 is going to be decreasing forever. And now notice that it's neither increasing nor decreasing, meaning it's constant between the values of -1 and 4. That's a perfectly flat line in that interval. Now that's it for increasing, decreasing, and constant portions of a function. We just have to make sure that we're answering in the proper interval notation, with those brackets facing the proper ways. So that is it for the properties of a function. Remember, properties just means characteristics of a function, and we'll leave this graphic on the screen to remind you of what each of them are. Now you can pause the video at this point, take a screenshot or a picture to help remind you what these properties are. But really it would be best if you found a way to make your own graphic or your own little reminders on what these properties are and how we answer them properly. And remember, when you're doing that, write yourself a little reminder about what those open circles and closed circles mean and how they change the square brackets when we write an interval. Now watch one good example here of how we might see questions pop up on the properties of functions.